Into the Vertical Blank.
Hi, this is 8-Bit Jeff from the Into the Vertical Blank podcast and this YouTube channel. This is basically number 4 in our STOS series, although we're not going to go through any code this time. We're going to talk about me attempting to use what I've learned in STOS over the last couple years and what I used in 1989 also, the mistakes we made in 1989 and things I've learned primarily about MissingLink, the MissingLink Extension, to try and make a horizontally scrolling shooter. Things they say are impossible to do on the Atari ST originally, and probably impossible to do in STOS, maybe the original version of STOS, although there was a scrolling command. We're going to try it with MissingLink. So, the first thing that I did was download and take a look at a couple screens of Scramble. That's the game I want to make. And as you can see, the Scramble screen is portrait, not landscape, and the Atari ST screen is the landscape. One thing we could do that some people did back then was chop off the entire side of the screen and also squeeze in the screen here. I'm not quite sure we're going to do that. Right now I'm trying to use the entire Atari ST screen within reason. Obviously we have a static score panel up here and we have a static panel at the bottom. We do have some places where we could have static scrolling areas. So in the area it looks like it's scrolling, looks like it's gameplay, but it's actually static. But let's take a look at what we started with. So I started with these. These are the sprites. Let's go even bigger on these sprites so we can see them even better. These sprites, somebody ripped them from the arcade game. I did not rip them from the arcade game. I'm also not using these actual sprites. I'm actually taking these. These are 32 by 20, I think. Yeah, about 32 by 20. And I'm redrawing them to spec in the Atari ST STOS's sprite designer. The colors, there are enough colors. There's 15. That means there's less than 15 colors. That means I don't have to split the palette half and half in STOS to have a 16 at the top and 16 at the bottom for some reason. We could also split it 3 times. That all of that takes some of processor time, and we don't have those cycles to spare trying to make a horizontal scroller in STOS. No, this is not as complicated as R-Type, but obviously in STOS you have some limitations. Even with the compiler and MissingLink, you're missing a few cycles that you would get if you're using pure assembly language. So what I have so far in STOS is I've created this ship in all 8 frames with 4 colors. Actually, I think it's got 5 colors. I've taken some of this terrain. I've also taken these graphics. These are your fuel panel, and these first, second, third, and those are static, and I have not yet created a font. I'm going to create a font. The font designer in STOS leaves a lot to be desired. I may use the STOS's standard font. It looks really close to this. 8x8 fonts look similar. This is very close to what the STOS font looks like. Let's give some props where props are due. These sprites that I'm copying from, not digitally stealing, but really remaking, were written by 125 Scratch. I'm going to give him credit for doing all the work of pulling them out of the arcade machine. These are actually Konami and Stern copyright. And we're going to do a tribute. So let's take a look at what I did in STOS first. So right back here is our code. Here is the stoscoders.com plugin for STOS. I'm not going to show you all the code. This is my latest version of the code. It is 133 lines to show a demo, plus some things you see that are commented out. And this current version does things like this. It removes loops that have to update on every frame with things that are part of the MissingLink with many add removes the need to check the scrolling position of every single tile that's on the screen. And right now we are looking at in some versions 64 sprites that I'm scrolling across, or 63, and another version 43. But you don't have to loop through all those and check the positions if you do this right. All you need to do is use this. Now, in STOS, you'll see this speeds it up. When it's compiled, it doesn't speed it up much because the compiler already does this. Now, we'll get out of that a little bit. Let's show something on the screen. That's what we're all here for. Let's look at the first version that I created. It's called Demo 3. Demo 3 is the first time I got things on the screen and added my frame rate counter so I could see how well I was doing. I wasn't that impressed with how well I was doing, to be honest. You'll see. Right now, running on here, you're going to see that when my frame rate counter starts and catches up, I'm running at 7 frames a second. I have three rows of 16 by 16 Bob sprites at the bottom animating, and I have a 32 by 20 spaceship sprite. I'm only getting 7 frames a second. If you look back at the game, though, I'm going to need a lot more than that, or at least I'm going to need to fake a lot more than that. Look, there's top and bottom. There's a lot of space here. Now, I have decided that I'm going to have to take some liberties with the game. I want it to play fast. I want it to feel like the arcade game. We may have to lose some of this, and we also don't have the exact height. So we're going to have to take a little bit of liberties with the game. But this isn't going to cut it. Even in the interpreter, this is too slow. So what I did was I took all of the math that's happening, including all of those many ads that you saw and pointers to most of these tiles, not all of them. And in Demo 4, I created this in STOS that runs pretty well. So we've effectively, don't worry about the black bar, it goes away after one run. When our spaceship starts animating, we've effectively doubled our frame rate. We're at 13 frames per second, and that's just by doing some math optimizations. And some loop optimizations. That's good. That helps in the interpreter. We'll see when I show the TOS version, the compiled version, it doesn't help a lot in the compiled version. I'll show you what does help a lot in the compiled version, and something we're going to need to do more of optimization-wise. It's going to mean making choices. Demo 5. When this one gets up and running, you will notice it's running a lot faster. It's going to start running at 17 frames a second in the interpreter. That's pretty good for the interpreter at the moment. The top static score panel, the bottom fuel plus where it shows your ships, those are static. Those are not drawn, those are not erased. I'm limited the size that's washed on every frame to be smaller. That helps speed this up. I also made sure that all of the sprites and the joeys, which are the single colored joeys that you see in the bottom two rows, those all use pointers to their arrays. That is a static pointer, static variable that points to the static pointer. That's actually much faster for this interpreter. And at the bottom at the moment, that is actually static at the bottom. There's a static. The screen is static down there. It's not being updated. We are updating the frame rate counter in the black, but the gray is not being updated. What does that do? It effectively gives us 3 or 4 more frames in the interpreter. Now, while we load up, we're going to load up TOS. While we load up TOS, we're going to talk a little bit about what we can do next. The next things to do is to double the width of those Bob sprites. Those are pre-rolled Bob sprites. Double the width of the Joey sprites. Those are the single colored sprites. Why do we do that? Less to update. Will that help? I don't know. I may want to double the height of them also in some cases. I need to have fewer things updating. Like I said, right now effectively 43 sprites are being updated on every frame. That's too many. The other thing we're going to be able to do is to test out using the actual MissingLink world command, which lets you horizontally scroll. I've not done that yet. That uses 16 by 16 tiles, I'm pretty sure. You may be able to use bigger tiles also. I think it only uses 16 by 16. That's why I have these 16 by 16 tiles, so I could get in there and use them if I need to. Don't know which of those are going to work. Those will happen in the next 2 demos. Let's look at the 3 demos again for Scramble, and I'll show you what the compiled version look like. They look a lot different. Well, they look the same, but they perform better than the interpreted version. Here's demo 3. Here's the first one again. Does not have the top and bottom score panel. Off the bat, no optimizations, and trying to push the 3 rows of tiles, that's 63 tiles at the bottom, plus the ship, you get 17 frames per second off the bat. Now it looks pretty good. We were getting 7, remember, in the interpreter to do this. Compiler for STOS, pretty damn good. We're going to, okay, now we're going to load in demo 4.tos. This is the one where I did some of the math optimizations. Again, don't worry about the black bar. I've gotten rid of that in the next version. We start seeing, we're still at 17. What happened? Well, this is where in the interpreter we went from 7 to 13 by doing all the map and loop optimizations. But in the compiled version, those don't matter that much. Why? Because the compiler already optimizes that code. So it does help with the interpreter, though. It's nice to make sure that everything is as optimized as possible in the interpreter, because that means we're going to get the best version no matter what. Even though it didn't help with the compiled version, we want to have a fast interpreted version also, just so we know we're writing the best code possible. Now, demo 5 is where everything comes together a little bit, at least for this version. So demo 4, again, static top and bottom. We have a smaller screen, and we're getting 24 to 25 frames a second. We're moving 44 tiles. We do have the static gray tiles at the bottom. Those do not update. And then we also have the ship. So that is 45 sprites moving at 25 frames a second. Yes, some of them are single color sprites on purpose. We do need other things on this screen. We need missiles. We need a star field background. Those are going to use the point and bullet commands that are part of MissingLink. We do have other sprites and things to happen in explosions. So obviously we can't use it all in terrain. So what are we going to do? Optimize, optimize, optimize. And obviously maybe I'll have to cut a column on the right and left. But to do that, I have to draw something every frame to cover it. That could, drawing that every frame to cover it, that's going to be a long sprite. Is that, on both sides, is that any better than drawing the tiles? I'm not sure. So I have to look into it. We're going to have to do some tests on those. But what we're trying to do is we want to get a speedy arcade conversion done in STOS for the Atari ST. And when we move to the STE, we're going to be using the same code base, but we're going to be able to have hardware scrolling, and we're going to use the blitter if we need to for some of the bigger sprites. And we're going to use MissingLink if we can for some of it, because MissingLink draws very fast. We'll see what we can do. But for now, this is what we have, 25 frames per second moving. And obviously, I need to optimize more to get more on the screen and have some gameplay. Okay, that's demo number 1 of Scramble, the Atari ST port attempting in STOS. Until next time, into the vertical blank.
Into the vertical blank, generation Atari. Into the vertical blank, generation Atari.
Into the vertical blank.
An 8-Bit Rocket Studios production.